Next example. Again, net ionic equation. Again, I'm not going to use the states of matter when I do my half reactions. I'm going to throw those in the finished product because they get in my way. Step number 1, assign oxidation states. So I have a +1 here, -1, that's an element, -2, that's 6, and 6 plus some number to be a -1, that number is going to be 5. -1 for chlorine, unless it's attached to fluorine, which it's not. So -1, there's 6 of them, that's a -6. A -6 plus some number being equal to the -2 part would be 4. And this is where my basic math skills start failing me terribly. -2 times 2, that's 4, so the nitrogen's a +4. -2 and +1. Alright, so I've assigned oxidation states. I see that my tin went from 0 to +4, and my nitrate went from +5 to +4. I always go to the reduced one first because it just makes more sense. Reduced means a gain of electrons. You're becoming more negative. You're reducing down in oxidation state. I went from a +5 to a +4, so it's being reduced. That means it's the oxidizing agent. My tin is going from 0 to +4. It is becoming more positive. That means it's losing electrons. That means oil, O-I-L, oxidation is lost. So the tin is being oxidized. And of course it's being oxidized by the nitrate. And it is the reducing agent. It is reducing the nitrate. Alright, so assign oxidation states. Pick your half reactions. Again, I start with the reduced. My reduced half reaction is going to be, what is it? The nitrate to the nitrogen dioxide. Now this is my methodology and it works. So you know what? Just follow it. To the nitrogen dioxide. And my oxidized is gonna be the tin to the tin chloride. So my tin to the tin chloride. Now you will notice that I suddenly am stuck with some chlorides here which aren't here. Don't panic. Go back to your reaction. You will notice I have chlorides in the original reaction, chloride ions. I'm just going to drag them down. I can use what I need. I'm going to drag them down to my oxidized and put them in as a reactant because that's where they are anyway. Step 1, balance the non-oxygen hydrogens first. In my reduced nitrogen, the nitrogen is good. In my oxidized, tin is okay, but my chloride ion on the left needs a 6. It's balanced atomically for the non-oxygen hydrogens now. Balance your oxygens using water. In my reduced, I have 3 oxygens there, 2 there, so I need 1 water. I don't have any oxygens in the oxidized, so I don't have to worry about it. So with my reduced, now that I went and balanced my oxygens, I need to balance the hydrogens. I have 2 on the right, so I use the hydride or the hydrogen ion to balance my hydrogen atoms. Electrically, I've got a +2 -1, that's a +1 over here, and a 0. Reduction, is a gain of electrons, gain, reduction, reactant, gain of electrons, left-hand side. How many? One. One negatively charged electron will neutralize, added to come up to be 0. Oxidized. Oxidized is a loss of electrons. They're going to be on the product side, loss of product. 6, that's a negative 6 plus a 0 because that's element, and this is a negative 1. So some negative 6 and a negative 1. That's going to be, no, there's something wrong here. What's wrong with this picture? That doesn't sound right. Hang on a minute. I'm going to go back. I think I made an error rewriting something. Oh, yep. Be very careful. This happens to all of us. I rewrote it wrong. My apologies. Always be careful rewriting this stuff. That's a negative 2, that compound. Whoosh! Glad I caught that. So that's going to be negative 6 to a negative 2. And that's a total of 4 electrons, correct? Negative 2 plus 4 will be negative 6. Yep. Okay. Glad I caught that. Now I'm going to clean up a little bit here because I got so much junk all over the place. I'm going to get confused. I'm going to confuse myself. There we go. And get rid of that. Looks like 20. Alright, so here are my 2 half reactions. Be careful, because even I do it. Be careful when you rewrite. Be careful when you assign the oxidation states of the elements, because it's just easy to make mistakes. For example, just what I did. Alright, next I have to make the number of electrons equal. I am going to multiply this whole thing by 4. Now you will notice I don't have to do anything to the second one, or you can look at it as just multiplying by 1, whatever. But I got to make them equal. That's going to be 4 total electrons transferred. Right? Lost by the oxidized, gained by the reduced. The oxidized is losing electrons, the reduced is gaining electrons. It's got to be the same amount. So I'm going to do the math. 4 nitrates and 8 hydrogens and 6 chlorides and a tin. 4 nitrogen dioxides, 4 waters, and a tin chloride with the correct charge on it. Oh, heavens to Betsy. Still can't get that one right. There we go. Alright. I am going to clean it up and add in my states of matter and check it. Four nitrates, that's the only spot for 4 nitrates, so it stays put. It stays as it is. It is an ion. If it's an ion, it's aqueous. I have 8 hydrogens on the left, none on the right, so it stays put also. Which of course correlates because my oxidized, I didn't need any. I don't have any oxygens or water, or oxygens or hydrogens. Ion, it's aqueous. 6 chlorides. Aqueous because it's an ion. My tin is a metal at room temperature. That is a solid. Ooh, that doesn't look good. There we go. Solid. Let's see. Nitrogen dioxide is a gas at room temperature. Brown, relatively poisonous. At room temperature, liquid water. Nothing's going to cancel with it, so the liquid water. And the tin hexachloride, which is a complex compound, complex ion, aqueous. Alright, let's check our work. I've got 4 nitrogens on the left, 4 nitrogens on the right. 4 times 3 is 12. I got 4 times 2, that's 8, 9, 10, 11, 12, so 12 oxygens, good. 8 hydrogens on the left. 4 times 2 is 8 hydrogens on the right. 6 chlorides, a tin and a tin. Yeah! Atomically balanced. Good start. Boy, that charge would have messed me up too. I would have done all this work. Alright, electrically, here's where my math skills fail me. Let's see, that's a -4 and a +8. That's a +4. But then this is a -6, so -2 charge. I'm going to write that down. Let's see, -2 charge on the whole left side. There's a 0. That's elemental. It's 0. And a -2. Yay! There's my -2. I am balanced electrically. My math skills are improving. And you are going to get lots of practice on this stuff.